All right, so this is on 7.2. Our objectives for today are you'll be able to graph and recognize inverses of relations and functions, and then also find inverses of functions. So remember, inverses are things that cancel each other out, like the inverse of addition is subtraction, the inverse of multiplication is division, and so on. So we've worked a lot with inverses this year. The first thing is to graph inverse relationships, and we can do that two ways. The first way, you can reflect the graph over the line y equals x. The second way, which I think you'll probably like easier, is you can switch the x and y values and then do the graph. So, as an example, if we took the ordered pairs, and let's let our x values and our y values, so let's go, we're going to go 2, 4, 5, 6, and 7. And then the y values will be 0, 1, 2, 4, and 8. So if I was to graph this on a graph, at 2 we're at 0. At 4, we're at 1. At 5, we're at 2. At 6, we're at 4. And at 7, we are at 8. So that would be graphing those points. And if I connected them then, would look something like that. So I can graph this. You can reflect the graph over the line y equals x. Well, remember the line y equals x would be 0, 0, 1, 1, 2, 2, 3, 3, and so that would be a line that looks something to this effect. Okay? And we can reflect it over that, but you can see where the difficulty arises in this and knowing exactly what space to put that in. So an easier way to do it is you can just switch the x and y values. So I can, when we do inverse functions, we're going to write it this way, to the negative first power, because the negative 1 remains 1 over f of x, which is the inverse. So I can just switch these, and my x values and my y values just switch. So this becomes 0, 1, 2, 4, and 8. And my y values become 2, 4, 5, 6, and 7. So now let's graph that. So at 0, we're now at 2. At 1, we're at 4. At 2, we're at 5. At 4, we're at 6. And at 7, we are at 8. Okay? And again, my spacing isn't, but you can see what this should happen is it should come out and be reflected over that line. So my spacing's off, so it doesn't look just right. But you can see how much easier it is just to switch those values to get the inverse. So when you're doing these, the easiest thing to do, we can take any values. So let's let x be 2, 4, 6, 8, and 10. And my y values, let's go negative 3, 1, 5, 9, and 13. So if they ask you to find the inverse of this, this is my f of x. So my inverse of that would simply be switch the x and y values. So this would become negative 3, 1, 5, 9, 13. And my y values become 2, 4, 6, 8, and 10. And I've got the inverse of that, and if they want me to graph it, I can plot those points to get the inverse. So that would be if you have a graph and you want to find the inverse of that. We won't do that a lot. but it's fairly easy to do. You just switch the x and y values. To find inverses of a function if it's in an equation form, again, we're going to have two ways to do this. The first one is you can use inverse operations. So let's say f of x equals x plus 3. So the inverse of that would simply be the inverse operation of addition, which is subtraction, and so that would become x minus 3. If it was multiplication, let's go 5x, then the inverse, again we write f of x to the negative first power, would be x divided by 5. So it's fairly easy to do with simple equations. When we get to more difficult equations, let's say it was x plus 5, and let's go x divided by 3 plus 5. Now here's where you have to be careful, because the inverse of this, you have to do it in the inverse of the order you would do them in. So I would first of all multiply by, or this is divided by 3, then I would add 5. So to do the inverse of that, I have to subtract 5 first, and then multiply by 3. So I'm just going to... Okay? So it gets a little complicated there. An easier way to do this is the second method. And the second method is simply switch the x and y and solve for y. Remember when I write this, let's go back to this equation. Remember, f of x is the same as writing this as y. So I can write this as y equals x plus 3, and then x divided by 3 plus 5. And now all I do to find the inverse is I switch the x and the y values. And now I solve for y. So our order of operations would tell us to subtract 5. So I just subtracted 5 from both sides. And then, to get rid of the times 3, or divided by 3, we would multiply both sides by 3. And so you can see that we get the same thing. The inverse is 3 times x minus 5, which is what we got when we did it this way. I would recommend with the more difficult ones that you use the second method. It's just a little bit easier, especially as you get into harder problems. So let's say I had f of x equals 3 times x plus 5 minus 7. Let's take a problem of that difficulty. So to find the inverse, remember this is my y value, so I switch my x and y. So x equals 3 times y plus 5 minus 7. So I can simplify this, distribute the 3. 3y plus 15 minus 7, which gives me 3y plus 8. Then I subtract 8. And, subtract 8. And so I get x minus 8 equals 3y. And then divide both sides by 3. And so my inverse function is x minus 8 divided by 3. And we have the inverse that way. So it's really easy if you just switch the x and y values and solve for y. One problem you run into and it's important that you remember this, really important, you cannot switch the variables in real life situations because the variables are named for specific quantities. So they're not naming the same thing here, they're just numbers when we do an equation. But when they're real life situations, we have to solve it a different way. And so to take a look at that, I've got a story problem here for us. So, it says a clerk needs to price a digital camera returned by a customer. The customer paid a total of $103.14, which included a gift wrapping charge of $3 and a sales tax of 8%. What price should the clerk mark on the tag? Okay, and this is in your book on page 500. All right, so if we write an equation for this, the cost of what a person pays for the item would be whatever the price of the item is, plus the wrapping fee, and then you're going to have to times that by the sales tax. Now remember, the sales tax was 8%, so you're going to pay 108% of the price of the bill that you get for the item and the wrapping. So now we just solve for P to figure out what the price would be. So we go C equals, I'm going to go ahead and distribute the 1.08. Subtract $3.24. And divide by 1.08. And so we get C minus 3.24 over 1.08 equals the price the item was. Now in this case we know we can go ahead and plug in $103.14 into our formula now, and we can find the price. But this formula, this would be the inverse formula, so that we can find the price of any item that was returned and know what to put it on the shelf as. So inverses, you just have to be careful. Make sure, again, if we recap this, to graph it, the easiest way, just switch the x and y values, and you can plot the points to get the inverse. When you have an equation, again, you can do inverse operations, works great when you have easy problems, but it's much easier just to switch the x and y values and solve for y. All right? And then lastly, you have to remember you can't do that. You can't switch the values when you're working with real life situations because they represent different things than just numbers on a graph. So, your assignment for the 7-2, page 501, 19 to 33, the odds, and hopefully this makes it easy for you.